In this session, we are going to discuss about Lakehouse. So, if you're someone looking to understand a Lakehouse, you came to the right place. The most important question: what we exactly have in Lakehouse? Why companies are moving towards Lakehouse? So, let's begin. So first of all, we are going to discuss two topics. Before I explain you Lakehouse, I believe that you need to have understanding of what traditional BI architecture look like. Then after that, we will discuss about problem we have with the traditional BI architecture. Okay, so we'll discuss about then Lakehouse, benefits, and finally we'll also look at the internal architecture of Lakehouse, how it actually works. Okay, so all of these things we are going to discuss one by one. So let's talk about traditional BI architecture. So what we have in traditional BI architecture, any BI project, you'll find that we usually have stories. Nowadays people are using data lake. So I can say this is data lake. Okay. So what we have in our data lake, we usually get a raw data. It can come from various sources. Depending upon what kind of business we are running, we could have different number of sources. Either we can get data via API or database, or there are various sources from where we could get data in our data lake. And here our data is stored in raw format or raw data. Okay, so what we do in traditional BI, we take this raw data, then we do some transformation as per business need. So after transformation, what we do, we usually store this data to our database or data warehouse. This can be a database or data warehouse depending upon what amount of data you have. So let's discuss a bit about data warehouse versus database. So database basically used for OLTP purpose. So we usually do online transaction. That kind of data we usually store in database, online transactional purpose. And this is optimized for CRUD operation. That means for single record. This is very good whenever you have a plenty of records in your table and you only need to modify one record or two record. At that time, this works really well. So this is what database. It is mostly any application that you use, people prefer to keep database where user is interacting. Whereas when we talk about data warehouse, it is mostly for analytical need, online analytical processing. You might have heard this term, online analytical processing. For this one, OLTP. OLTP. I'm not going to discuss this in detail. I'm just giving you an overview. This is very good if you have to perform aggregation. This stores our data in columnar format. This one stores record row by row. So it makes sense, right? Because in database you store your data row by row, easy to modify. Whenever you have to perform aggregation like mean, max, average, and there are other kind of calculation that we do on a particular column, and that is faster in data warehouse. And I hope this gives you enough idea why we need database or data warehouse. So after this transformation, we store our data to data warehouse or database. Depending upon project need, either people usually do some analysis directly on data warehouse, or they again take this data, we feed to Power BI, and here we will have end user who will be doing some analysis. So this is how a traditional BI architecture look like. We are going to discuss about cons of this. It is relatively very simple to figure out what is the problem. We had data in our data lake, then we did some transformation. For transformation also we required some compute, right? We needed some compute for transformation. We use database power itself, because database again also provides some compute to modify or transform data, or we can use altogether an independent separate tool and write to database another compute, Synapse or Databricks. The problem here, you see the number of software services we have to maintain for this project. First of all, we need data lake. We also need data warehouse, two software, and sometimes optionally, we also need some transformation compute. So there are at least 3 software we need. What if I say we can remove this part, remove this database part from here? Wouldn't it be better? That is what Lakehouse provides. So with the help of Lakehouse, you don't need database anymore. That is the power of Lakehouse, and that is why company are moving towards Lakehouse, because now they don't need data warehouse software altogether, because that thing can be done with the help of Lakehouse itself. The question is, if we are going to remove this data warehouse, definitely data warehouse was providing some capabilities in order to make our work easier, right, for Power BI. Now if we are going to remove this software altogether, how we are going to do those tasks? That is our next question. So if you look at data warehouse capabilities, we use it for online analytical processing, aggregation, columnar format, and also it provides ACID feature and then rollback, all of these things. What if I say we have a way to do all of this within data lake itself? There is a file format which gives all of these features in data lake itself. The question is what this file format is. Now I think you got enough understanding about traditional BI architecture and why we are removing it and how we are going to bring this thing into data lake. Now let's move ahead and focus on Lakehouse. So in Lakehouse there are two things. One is our data lake and another one is delta file format. When we combine these, we make Lakehouse. That is what Lakehouse is. Data lake plus data file format. But here there is one more catch, is that to work with this delta file format you need one compute. Here also I told, right, we would need one compute in order to do the transformation. So to create this delta file, even to manage this delta file, to read data from delta file, we would need one compute. So basically this compute power you can configure. We have Databricks which gives Spark. There are so many software that you can connect to this data lake and you can transform your data and create delta file format. So this is somehow like the engine which reads your raw data, transform them and store them in delta format. And if you want to read them, then again you are going to use this kind of software to read those files. What is this? This is storage and this is compute. Using compute, you take your data, you do some transformation, you write it back, you store it. Now we have this dashboarding software, Power BI. Power BI can directly read file, or you can use in between software as well. You can use Synapse or Databricks, you can use even Power BI directly. You can still access your data from data lake directly. So in this architecture, if you look at, there is no need of data warehouse. In our next video, we are going to discuss about delta file format to understand how delta file format is capable enough to provide all of these features. So until then, bye. See you in the next session.